Welcome to our paper on better practices for domain adaptation in the AUTOML 2023 conference. The field of domain adaptation is concerned with learning over distribution shifts. In particular, the common setup is to learn a model on an unlabeled target domain by using a related source domain. Examples of this include adapting a model trained on medical images from one country to images from another country, or a model trained on bread recipes to cake recipes. There are several settings in the literature which differ in what data is available to the model at what time. In unsupervised domain adaptation, the model sees the labeled source and unlabeled target domain simultaneously. In source-free domain adaptation, the model sees only the target domain after potential pre-training on the source. And in test-time adaptation, the model sees only a single batch or data point from the target domain at a time and must adapt to it before being evaluated on its predictions. Our goal is to bring domain adaptation closer to the AutoML community by automating the pipeline. Such a pipeline might consist of a dataset or features being fed into an AutoML black box, along with an optimization metric and a compute budget. Inside the black box, we may find hyperparameter or neural architecture search, among other things. The key problem that makes it difficult to realize such an automated pipeline is that in domain adaptation, the model never has access to target domain labels, and therefore we have no validation loss to use as an optimization metric, as we would in a standard supervised setting. So the choice of an optimization metric on unlabeled data is the key problem that we want to tackle in this paper. Our aim is to determine whether any other validators give consistently strong results such that they could be adopted as the metric in an AutoML pipeline. In our larger benchmark, we have found that the optimal validator is setting and algorithm dependent. No validator is clearly ready for the AutoML pipeline, unfortunately, but we might recommend, for example, vMeasure for UDA and SFDA, or RankMe for TTA. We have some surprising results in that source only can be competitive with UDA when using RankMe or MMD validators. Validating in SFDA or TTA often fails catastrophically, and we have found no easy way to make it fail-safe. TTA completely fails on more complex distribution shifts, such as office home, meaning that sometimes adaptation is actually not worth it.